Have you ever wondered what an operating system like Windows or macOS actually does? We often think of it as the program we use, but its most important job is to be the ultimate manager. It's in charge of managing all the different parts of your computer, the hardware. But before we can understand the manager, we have to understand the employees. The most important employee? The CPU, the central processing unit, the brain of the computer. The CPU needs to talk to all these different parts. The hard drive to get data, the keyboard to receive your typing, and the graphics card to show you a picture. But how does it know who to send the message to? It's like a boss in a huge office with no names on the doors. The solution is simple but brilliant: addresses. Just like every house on a street has a unique address, every piece of hardware in your computer has its own unique address or a range of addresses. When the CPU wants to talk to the hard drive, it sends out a message with the hard drive's address. The hard drive sees its address and says, "That's for me." All the other devices simply ignore it. The computer world has three main types of addresses, like different neighborhoods in a city. Most of the memory addresses are for your RAM. It's a huge neighborhood where everything lives. The first part, the low memory section, was for old computers. A special part was even set aside for the video card, so you could literally write text to that memory and it would appear on the screen. But today, most of that is legacy. The most important part for us is the BIOS, which wakes up your computer and loads the operating system. The rest of your RAM, from 1 MB and up, is where the real action happens, where your OS, programs, and data live. For a long time, devices like keyboards and mice had their own separate small neighborhood of addresses called I/O addresses. The addresses were standardized, so a keyboard's address was always the same, no matter the computer. This was great for compatibility. Every program knew exactly where to find the keyboard. Even today, your modern PC maintains this backward compatibility, so it can still understand and work with old standards. It's why your computer still expects a keyboard to be at a specific address. But that small I/O address neighborhood quickly ran out of space, so a new solution was invented: memory-mapped I/O. Instead of a separate address space, devices now map their addresses into the vast, unused space of the RAM's address map. When the CPU tries to talk to this part of memory, the message gets rerouted to the device instead of the RAM itself. It's like a device claiming a vacant lot in the RAM neighborhood as its own. So who decides all these addresses? There are two main ways. For a long time, a standard called the IBM PC standard dictated where everything should be. This was great because it made it easy to write software that would work on any compatible computer. The operating system could always assume the keyboard was at a specific address. But what about new devices? That's where plug and play comes in. When you boot your computer, the BIOS acts like a helpful host. It detects a new device, asks it how much memory it needs, and then assigns it a space in the memory map. This location isn't fixed and can be different every time you boot, but the BIOS keeps track of it. This allows for much more flexibility and efficient use of the computer's resources. So, what does this all look like inside your computer? At the heart is the CPU. It connects to other CPUs and parts through the front-side bus. A key component is the North Bridge, a central hub that talks to your RAM and other fast devices on the PCI bus, like your graphics card and network controller. Then there's the South Bridge, which connects to all the legacy devices that don't need to be super fast, like your keyboard, mouse, and speakers. This two-bridge system is a common way to organize all the hardware so the CPU can communicate efficiently with everything. Everything works together in perfect harmony to make your computer function seamlessly. The final piece of the puzzle is how the processors themselves have evolved. We started with 16-bit processors that could only talk to 1 MB of memory. Then we moved to 32-bit processors, which could address 4 gigabytes. Now we have 64-bit processors that can handle massive amounts of memory. But a key factor in this evolution? Backward compatibility. Intel and AMD made sure that old programs could still run on new computers. It's a testament to good design and why your OS and applications can run on such a wide range of hardware. So, the next time you boot up your computer, remember that underneath the sleek interface is a world of addresses, bridges, and standards. It's a complex but elegant system that allows your operating system to manage every single piece of hardware seamlessly. This foundational knowledge is key to understanding how your computer truly works.